You know, in science, we have a theory that is so incredibly successful, it's basically the foundation of our entire modern world. It's called quantum mechanics. But here's the thing. It has this one tiny universe-breaking flaw, a single crack in its foundation that could change everything we think we know about reality.
Seriously, think of this like a cosmic detective story. We've got this code that describes reality almost flawlessly, but there's a bug, just one, and it's a contradiction so deep that the world's best physicists have been stuck on it for 50 years.
And when I say flawless, I really mean it. This isn't just some abstract idea on a blackboard. Quantum mechanics is the reason you're holding a smartphone right now. It's why we have semiconductors, lasers, GPS, MRI scans, you name it. Its success is absolutely spectacular.
So just how successful are we talking? Well, its predictions are the most precise in all of science. Get this, optical clocks, which are built on quantum principles, are so accurate they would lose less than a single second over the entire 13.8 billion year history of the universe. That's a level of precision that is just mind-boggling.
Okay, so what is this almost perfect code for reality? What are these fundamental rules that seem to govern everything from a single speck of light to the most complicated molecules we know of? Well, it turns out the basic recipe is actually surprisingly simple.
The whole quantum world, and yeah, that means our world too, it really just runs on two core principles. And these aren't just special rules for certain particles. No, this is the universal template for reality itself.
All right, rule number one is linear superposition. This is the one that gets all the headlines, the famously weird one. It basically means a particle, say an electron, isn't in any single place until you actually look at it. Instead, it exists as this fuzzy wave of all its possible locations all at the same time. It's a blend of probabilities.
And that leads us straight to rule number 2, indivisible detection. The very moment you measure that electron, the moment you look, that whole fuzzy wave of possibilities instantly collapses into one single definite outcome. It just snaps from being a blend of everything to being just one thing.
Now, the really wild part is just how universal these two rules are. We're not just talking about light or electrons. We have seen these laws hold true for whole atoms, for giant molecules made of 2,000 atoms, and even for things you can see, like superconducting circuits. Superposition and collapse. That's it. That's the template for everything. Except
for one place. The one spot in the entire universe where these perfect, unbreakable rules seem to completely and catastrophically fail, right at the edge of a black hole.
See, the problem is what happens when you try to smash these two ideas together? What happens when the perfect rules of quantum mechanics run headfirst into the most extreme gravity in the universe? It's a clash of titans, and it creates a paradox that has stumped the greatest minds for half a century.
Here's the paradox in a nutshell. A fundamental, core law of quantum mechanics says that information can never, ever be destroyed. But Stephen Hawking figured out that black holes slowly evaporate over time. They leak out this random heat called Hawking radiation. And that radiation contains absolutely zero information about what fell in. So, where did the information go? It seems to be completely erased, and that should be impossible.
And this crisis has been going on for 50 years. Back in 1975, Hawking was sure the information was gone for good. But fast forward to 2019, and brand new calculations showed that somehow the information does escape. The problem is, the math tells us that it gets out, but it gives us zero clue as to how. We have a solution on paper, but we have no physical explanation for how it actually happens. It's maddening.
And, this isn't the only crack that appears where quantum mechanics and gravity meet. The theory also predicts the amount of energy in empty space, and its prediction is wrong by 120 orders of magnitude. That's a 1 with 120 zeros after it. It is literally the worst prediction in the history of physics. So yeah, in these extreme cases, our perfect code is definitely breaking down.
So what if the problem isn't with the code itself? What if the problem is that we don't understand the computer it's running on? A radical new idea is suggesting that the solution might not be in our universe at all, but somewhere else.
A new, and yes, very speculative paper from 2025 proposes something truly mind-bending. It asks, what if our entire four-dimensional universe is just a projection, a kind of shadow cast from a higher five-dimensional reality?
Okay, to really get this, let's use a simple analogy. Just try to picture our entire universe
As nothing more than a shadow on a wall.
A shadow cast by some more real, more fundamental object that exists in 5 dimensions.
In this picture, the reality we all know and experience isn't the real deal. It's just a reflection of something much deeper.
So, this is a pretty wild idea, right? But the big question is, could this bizarre new picture of reality actually solve the paradoxes that have had physicists tearing their hair out for decades?
Well, this new framework offers some incredibly elegant solutions. That black hole information paradox? Solved. The information isn't lost, it just goes back to the 5D reality it came from. The vacuum energy problem? Solved. That energy is just a feature of the 4D shadow, so it doesn't actually have any gravitational pull. Even gravity itself might not be a real force. It could just be the geometry of that shadow.
And this is the core idea, the beautiful part. In this view, the paradoxes aren't real problems in the first place. They're just illusions, projection artifacts, created because we have a limited 4D perspective. It's like trying to understand a person by only looking at their flat 2D shadow. All the weirdness is in the shadow, not the person.
So, this new way of thinking offers a potential path to finally fixing that crack in our most perfect theory. But it leaves us with an even bigger, more profound mystery. If our entire universe is just a shadow, what is the true reality that's casting it?